doing 3.4, solving multi-step inequalities. So let's start with those steps we talked about the other day. Quick reminder. Step number 1, we are going to distribute. If there's parentheses anywhere, we have to distribute. Step number 2, we're going to clear the fraction. And again, remember you have to multiply everything by the common denominator. Step 3, combine like terms on each side. This is a really important step. Step number 4, remember we wrote this a little bit different. We said move your variable term to the left. It has to be on the left. So move the variable term to the left. We're going to move our number to the right. The number or the constant. Step 6, we're going to divide by the coefficient on our variable to solve. And with that step 6, remember we put a little asterisk underneath it and we said that if we are dividing by a negative, we're going to flip the inequality sign. Okay, those are the steps we talked about the other day, right? Okay, so we're actually going to, start with example number 1. Example number 1, let's say I have -2 minus 4 times 1 minus 4x is less than -86. So, first step says we have to distribute because there's parentheses, right? So I have -2. I'm going to distribute the 4, or -4, because we take the sign with the number. So -4 times 1 is -4. -4 times -4x is positive 16x. We're to the end of the parenthesis. We're done distributing. I'm going to bring everything else down. Step 2 says to clear the fraction. I don't have any fractions. Step 3 says to combine like terms. Brandon, what can I combine on the left-hand side there? -2 and -4. Good. For a total of what? -6. Good. -6 plus 16x is less than -86. Step 4 says to move my variable term to the left. Is it perfect? Step 5 says to move my number to the right. Good. I'm going to add 6 to both sides. So I have 16x is less than -80. I divide both sides by 16, and x is less than -5. All right, so now we're going to graph it. At -5, do I have an open or closed dot? Which way does it go? Goes to the left. All right, interval notation starts with the arrow, so it starts with -infinity, goes to -5 with a parenthesis. So, give me questions on that process. Too easy? Awesome. All right. So let's step it up a little bit. All right, example number 2. Good to know. All right, let's go with -3 over 4x plus over 8 is less than or equal to x minus 10. All right. Times everything by 8. Why are we using 8, Brayden? Good. 8 is the common denominators, ladies. Okay, so we're going to times everything by 8. And again, I mean everything. Every single term. So here, 4 goes into 8 twice. So I have 2 times negative 3x, or negative 6x. Plus, here my 8's cancel, and I just have 5. Less than or equal to 8 times x is 8x, and 8 times 10 is negative 80. Any questions so far? The next step says to combine like terms. Do I have any terms to combine together? No. Okay, now I move my variable term to the left. So I'm going to subtract 8x. Subtract 8x. I need to have that term on the left. So I have negative 14x plus 5 is less than or equal to negative 80. Now I need to move the number to the right. So I'm going to subtract 5 from both sides. So I have negative 14x is less than or equal to negative 85. Whoops. All right, now what do I do? Divide by negative 14. Perfect. Because I am dividing by a negative, I have to flip this inequality to greater than or equal to. Negative 85 over negative 14 reduces to what? 85 over 14. That is it. So on my number line at 85 over 14, do I have an open or closed dot? Closed, because it's greater than or equal to. And which direction does my arrow go? To the right. Negative divided by a negative is a, okay. Interval notation, starting at that solid dot is a bracket at 85 over 14, and it goes all the way to infinity. Okay, any questions? So let's talk about some special cases. Special cases. All right. Special case, if the variable term drops out and the remaining is a true statement. Then we have infinitely, I better say then, there we go, infinitely many solutions. When we graph it on a number line, it is the entire number line. Your interval notation for infinitely many solutions goes from negative infinity to positive infinity. It is everything. Okay? That means absolutely any number makes it true. All right. If the variable drops out, and it is a false statement, then it is no solution. There is nothing on the graph. And the interval notation is actually a circle with a line through it, which means empty set. There is nothing that makes it work. It's going to be yes. Okay? So let's see. Example number 3. Let's say I have negative 2 times x minus 4 minus x is less than or equal to negative 3x plus 5. All right, so we have to do the distributive property first. There's a parenthesis up there. Negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8. To the end of the parenthesis, I'm done distributing. Bring down minus x is less than or equal to negative 3x plus 5. Now we combine like terms. So negative 2x and negative x is a total of how many? Negative 3x plus 8 is less than or equal to negative 3x plus 5. All right. Now I'm going to add my 3x to the left. Our x's drop out. I have 8 is less than or equal to 5. Is this true? It is not, so this is no solution. And we write in empty set for your interval notation. And you don't graph anything. Okay? No, it's not. Example number 4. No. Example number 4. Say I have 4 times x plus 1 plus 2x is less than 6 times x plus 4. All right, so first we have to do the distributive property. 4 times x is 4x. 4 times 1 is 4. To the end of the parenthesis, I'm done distributing. I'm going to bring down plus 2x. Less than. I also have to distribute on that side. 6 times x is 6x, and 6 times 4 is 24. Now I have to combine like terms on one side. Yes, 2x and 4x, or actually 4x and 2x, is 6x plus 4 is less than 6x plus 24. I'm going to move my variable term to the left. I'm going to subtract 6x from both sides. My x's drop out. I get 4 is less than 24. Is that true? Yes, it is. So this is infinitely many solutions. We would graph the entire number line, and our interval notation would be from negative infinity to positive infinity. Because my arrows go both ways, right? It covers everything, yes.
And because nothing can equal negative or positive infinity, you can't have the bracket.
Correct. Very good. Anybody else? Are there any questions? This is exactly what we were doing the other day, right? We really haven't done anything new other than I showed you infinitely many solutions, correct? All right. So we have a worksheet today. It's not a very long worksheet. It's only 12 problems. But I want to stress how important it is to show your work so we can figure out where the problems might be. Okay? All right. Yes.
Mm-hmm. Graph and
Interval notation. Yes, that is correct.